This is a video for AQA Further Pure. This is Matrices 1, Section 1.1, Basic Operations with Matrices. Firstly, we need to define what we mean by a matrix. It's simply an array of numbers which could represent data or other mathematical information. The size of a matrix, or the order, is the number of rows and columns. So we talk about for example, a 4 by 5 matrix. So this matrix here is a 4 by 5 because you can see it's got 4 rows and 5 columns. If we've got some particular information that we want to represent by this matrix, we may well give headings to the rows and columns. So here we've got one where we've got the matrix representing the results of 4 teams. Here are some other matrices, this time without any particular information, so these are purely numbers within the matrix. You'll see that A and B are both what we call square matrices, in fact both 2 by 2 matrices. C is a 2 by 1 matrix, so it has 2 rows and 1 column. The usual way of writing a matrix is to use a capital letter, or you'll see it in print in bold. When it comes to adding matrices, then the matrices have to be what is called conformable. Now for addition, that means that they must be the same order or same size. So it's possible for us to add A and B together, but we wouldn't be able to add B and C, for example. Now when it comes to addition, it's a very straightforward process. We simply add together the corresponding elements in each of the matrices. So this is going to produce another matrix, the sum, where we have the first elements, 2 and -4, added together to give us -2, and then moving along the top row of each matrix, -3 plus 5 gives us 2, and then on the bottom row, 4 plus -1 is 3, and 1 plus 2 is 3. So all we're doing there is adding together the elements in each of the matrices. Well, having done A plus B, we might decide, well, we could look at what is B plus A. So obviously that would just be the matrices added together in the opposite order, and of course we're going to get the same result because this time we've got -4 plus 2, which is again -2, etc. So we get the same answer to the one above. Now when operations written in the opposite order produce the same result, we refer to those things as being commutative. Subtracting matrices, again, conformable means that we have to have matrices of the same order or same size, and it's exactly the same sort of process as for subtraction, but this time we're simply subtracting the numbers involved. So we're going to get 2 minus -4, which gives us 6 in the first entry, and then moving along the top row, -3 minus 5, -8. On the bottom row, 4 minus -1 is 5, and 1 minus 2, -1. So I leave it then as an exercise for you to check that when we do B minus A, we don't get the same result of that. So therefore we can say that B minus A is not equal to A minus B, so that matrix subtraction is not commutative. It's possible for us to multiply a matrix by a scalar, and to do that we simply have to multiply each element by the scalar. So 3a would be 3 multiplied by the matrix 2, negative 3, 4, 1, and each of the elements would simply be 3 times greater. So 3 multiplied by 2, 6, 3 multiplied by negative 3, negative 9, 3 multiplied by 4, 12, and then 3. And in a similar way, negative 2 multiplied by the matrix C, negative 2 multiplied by the matrix 3, 0, gives us an answer negative 6, 0. We now turn our attention to a problem that can be solved using matrices. So here we have two matrices that represent the position after the last 3 games and before. What we're asked to do is to work out what were the last 3 results if the fixtures were as given. Well, we could do that by trying to inspect it. However, if we subtracted the two matrices, that will give us the position of change. So taking the matrix for before away from that from after gives us the change that has taken place. That's a simple process to do. I'm sure you can check that that is the solution that you would get. We're looking at the top row of that matrix. We can see that City won their match, and therefore with goals being 2 for and 1 against, we can see that City beat United 2-1. Now going down to the final row, we can see that the other game that United played, they drew, and they've got a total for 2 and against 3. So therefore we must have a draw which is 1-1. And finally, looking at the final matches, Rangers against Town, we can see that Town had 2 against and 1 for, so the result there must be Rangers 2 and Town 1. Well, that's the end of this video. In the next video we'll look at section 1.2, multiplying matrices.